Alrighty, so we have done one part of Unit 8 where we went from mole to atoms or moles to molecules, moles to pieces is the main thing. So I want to add a page to show you what we're going to be doing. So I did mention this in class, but I'll mention it again here. Mole is kind of your home. This is where you always come back to. Look at my cute little house. And so we learned how to go to and from the atoms or molecules or ions. Just make sure that this, whatever you are considering an atom, molecule, or ion, that this is like a piece of it, like the actual piece, like a counting piece, not like the other two that we're about to learn. So to go from atom to molecules, atom to ions, atoms, molecules, or ions back to mole, you're going to be using Avogadro's number. Okay, and it's important to realize that the number 1 will always go with mole. Okay, the number that goes on each of these transitions go with whatever this like other unit is. So Avogadro's number is 6.02 times 10 to the 23rd. So this number will go with atoms, molecules, or ions, and then 1 will go with mole. Okay, so we are going to learn today another unit of this, I guess, this little conversion triangle I'm building. We are going to go from grams to moles or moles to grams, and so we will be using the molar mass to do this. And this comes from the periodic table. Okay, now it's important to realize that grams is not a like counting piece the same way that atoms, molecules, or ions. This is not a piece. This is a weight or mass. Okay, we are now dealing with something that we can measure, a mass. So the molar mass is, the molar means mole and mass means weight, like I was telling you. It's the mass of 1 mole of a compound. So basically, if 1 mole is 6.02 times 10 to the 23rd atoms, this is the mass of those atoms. Okay, it's of a compound or of an element, either way, or an ion. It is equal to the numerical value of the average atomic mass, which you get from the periodic table. All this is right here is just saying that the number off the periodic table, if we have carbon, it says like 6 at the top for the atomic number. The bottom says 12.011 or something like that. This number is your mass. That is also your molar mass. So 1 mole of carbon atoms is 12.01 grams heavy. Okay, 1 mole of magnesium atoms, we would need to go to the periodic table, which I assume I have in here somewhere. Okay, I guess I don't. I can look it up for you. So on the periodic table, we have for magnesium, magnesium's little square looks like this, Mg, and then it has a 12 for the atomic number, and then your mass is 24.305. So you can just write 24.305, or you can round this to 24 grams. So 1 mole of magnesium atoms is equal to 24 grams. Same thing for copper. Copper's little square looks like this. Copper, it's number 29. Its mass is 63.546. So 1 mole of copper atoms is equal to this number right here. 63.5 grams. Now it's important to realize that on this one, 24.3, I rounded that to 24 because the 0.3 is beneath 5. If it is 5, you're just going to leave it, okay? If it were above 5, you would round up, but if it's 5, just leave it. You don't want to round because that's like half a gram right there. Okay, so 1 mole of bromine atoms is equal to, we have to, again, you would need your periodic table out for this. Need to go to bromine. Bromine is this, 35. and then its weight at the bottom is 79.904. 79.9 is going to round to 80. So it's going to be 80 grams. So we can rewrite this as a fraction like we did for the previous ones, where molecular mass of bromine, we're going to rewrite it where you say 80, sorry, goodness, 80 grams over 1 mole. Or you can flip this, okay? You don't have to keep it as 80 grams over 1 mole. You can say 1 mole over 80 grams. So we are going to use these as conversion factors as well. So this is the molar mass I was talking about right here when we're going to go from mole to grams. All right, so if I have a compound though right here, I have SnOH2. So this is SnOH2. We have to get the molecular mass of the entire compound. It's not as easy as just looking on the periodic table. Now we have to consider each element in the compound. I have Sn, I have O, and I have hydrogen. Then we have to consider how many of them we have. I have 110, I have 2 oxygens and 2 hydrogens. And then we have to multiply that by the mass. So we're going to look on the periodic table and see that 10's mass is, it's number 50, its mass is 118.7, so I'm going to round that to 119. Oxygen's mass is, it's number 8, its mass is 15.999, so I'm going to round that to 16. And hydrogen, it's number 1, its mass is 1.008, so I'm going to round that to 1. So then you just find the sum of all this. That's 119, that's 32, and that's 2. Then you'll just add it all. So that's 4 plus 9 is 3, 1, carry the 1, 5, 1, 153. So that is the total mass of all of this. So the 1 mole of 10,2 hydroxide is going to equal 153 grams, okay? The molar mass, the way that we can write this, the way I just taught you, is if 1 mole equals 153 grams, we can rewrite this as 153 grams over 1 mole. And don't forget to keep SnOH with it. Okay, so that's how you find the molar mass of an element. We need to talk about how to go from grams to moles, how to work the problems. So again, you're going to use molar mass to go from grams to moles or from moles to grams. And you're going to use this as a fraction like I just did. So you're going to say the number off the periodic table, or what you calculate, over 1 mole, or you can say 1 mole over that number. So this is a separate conversion factor. We have another conversion factor right here. We learned this conversion factor at first. Now we're learning the molar mass conversion factor. So we're going to work it the same way, where we set up our problem, where we have our given and we have our goal right here. And then we just need to figure out how to go from moles to grams. And you notice aluminum stays the same. That's important. So the problem says aluminum is often used for the structure of lightweight bicycle frames. How many grams, that's our question, of aluminum are in 3 moles of aluminum? So we're not changing element to element, we're just changing unit to unit, mole to gram. So we're going to set it up the same way. I'm going to write what I'm given down here. I'm going to write what I'm given, 3.0 moles of Al. Okay, I'm going to use that fraction bar that I taught y'all to use. And if moles is on top, I'm going to put moles on bottom. So that means that on the bottom, I'm going to put 1 mole of aluminum, because I told you that 1 always goes with the mole. Okay, now currently I'm in moles and I'm trying to get to grams. Okay, so to go from moles to grams, I'm going to use one of these conversion factors. So since moles on top, I need to put grams of aluminum on top. Now I just need to look at the periodic table to figure out what number goes with grams of aluminum. So on the periodic table, this is what aluminum looks like. It's number 13. Its big number on bottom, I don't know why I made my box so small. Its big number on bottom is 26.982, so we're going to round that to 27. So the number that goes with grams of aluminum is 27. So then that makes moles of aluminum cancel, and I'm left with grams of aluminum, which is my goal. Okay? So then I'm going to put in my calculator 3.0 times 27, and I'll get my answer. Okay, let's look at the next one. Artificial sweetener, aspartame, NutraSweet, formula is C14. I'm going to write down this formula right here. C14, H18, N2O5. Okay? It's used to sweeten diet foods, coffee, and soft drinks. How many moles of aspartame are presented in 225 grams? So again, I'm going to write down my given, I'm going to write down my goal, and we're going to figure out how to get there. So I was given 225 grams of aspartame. I'm going to abbreviate ASP. And I want to know how many moles of ASP. So this stayed the same. I'm just going from unit to unit, grams to moles. So I'm going to write down what I have into my fraction bar. I am given 225 grams of ASP. Remember, this is ASP. Okay? And if grams is on top, I want to put grams on bottom. Remember, the number that goes with grams has to be calculated. So this number comes from the P table. But we have a compound right now. We have C14, H18, N2O5. So I need to calculate the total molar mass of all of those. So I'm going to get my calculator handy so that I can do this. So I'm going to take this compound out to the side and divvy it up into all of its pieces: carbon, hydrogen, nitrogen, and oxygen. The first thing I'm going to do is use their subscripts to tell me how many I have. I have 14 carbons here, so I'm going to write 14. I have 18 hydrogens, I have 2 nitrogens, and I have 5 oxygens. I'm then going to multiply that by the mass of each of them from the periodic table. So if you look at the periodic table for carbon, its mass is 12. Hydrogen's mass is 1. Nitrogen is 14. And oxygen is 16. So once I have these figured out, I'm just going to do the math for each of them. 14 times 12 is 168. 18 times 1 is 18. 2 times 14 is 28. And 5 times 16 is 80. Okay, that's all my individual pieces. I'm just going to add them up to get the sum. So 168 plus 18 plus 28 plus 80. That's 294. This is how many grams are in 1 mole of aspartame. So this 294 is what I just calculated to go in this spot right here. So how many grams of aspartame? 294 grams of aspartame are in 1 mole of aspartame. So then the grams cancel and I'm left with mole. So then I just do the math. 225 divided by 294. And it's 0.765. Okay, so just to summarize all of this, because I feel like I probably lost you. Okay, to summarize, we are now going from mole back and forth to gram. Okay, gram is a mass measurement. This is something we can do in class. We can use a scale the same way you measure your mass by using a scale, but you are measured in pounds. We're going to be measuring it in grams. Okay, so we can go back and forth from moles to grams of the same element by looking at what's called their molar mass. Okay, your molar mass is the mass in 1 mole. So most of the times this is just going to be equal to the number on the periodic table for the element. Okay, remember this is the big number with the decimals. Big number. If it's a compound, you're going to have to break the compound into its pieces, then add. So you're going to follow, if it's a compound, you're going to break it into like element A, element B. So like if I have A 10, B 14, I'm going to break it into A and B. The first thing I'm going to do is say how many of each I have. I have 10 and I have 14, according to these subscripts. I'm going to multiply that by the mass on the periodic table. Okay, that number you get from the periodic table. Once you know that answer to both of those, you just add them up to get the total grams per 1 mole. Okay, so when we are working these, we're going to, again, just be doing the same thing, where you start with what you're given and you work your way to goal. Whatever is on top, if we have grams on top that was given, we're going to put grams on bottom, okay? And we're going to put 1 mole on top. This number right here is from the periodic table, or we just calculated it. If your given to goal starts with a mole, then we're going to put however many moles we were given. Since moles on top, we're going to put 1 mole on bottom. And since we're trying to get to grams, we're going to put grams on top. And again, this number comes from the periodic table or from the compound calculation that we just did.